Have you ever, like when you're trying to put together some, flat pack furniture and you're staring at those instructions?
Oh, yeah.
Yeah. And it's just like, I can't figure out how this goes together.
Exactly.
Or like when you get lost and you're looking at a map and you just can't seem to orient yourself and figure out which way to go.
It's a struggle for some people.
Right. And that's what we're talking about today. We're talking about spatial ability
Yes.
and how it affects how we learn from visuals.
Welcome to the deep dive.
Yes, welcome to the deep dive. We're diving into something that's pretty fundamental to how we make sense of the world around us.
Absolutely.
So when we talk about spatial ability, it's not just about being good at those 3D puzzles or something.
Right.
It's really a whole set of mental skills.
Yeah, it is.
Like you mentioned, finding your car in a parking lot.
Yeah.
Or, picturing how a new piece of furniture is going to look in your living room. And I think a lot of people don't realize how much this set of skills affects so many different areas of life.
Oh, yeah, absolutely. And, if we go way back to 1993, there was a researcher named John Carroll who really laid out some of these core abilities involved in spatial thinking. And he talked about things like scanning a visual scene.
Right.
Kind of quickly looking around and taking it in.
Makes sense.
Apprehending the forms and shapes and positions of things.
Right.
Really getting a sense of the layout of things.
Yeah.
Forming a mental representation
right.
of that scene or that object.
Okay.
And then being able to manipulate that mental image in your head.
That's interesting.
If you think about folding a piece of paper.
Right.
In your mind and picturing what the creases would be, that's a classic example of spatial visualization.
I see. So there's this kind of spectrum, like some people are just naturally really good at this and some people might struggle with it more.
Exactly. And what's important is that Carol pointed out that this isn't just about overall intelligence.
Okay.
It's somewhat separate. Some people might be, incredibly intelligent in a general sense, but might have some difficulty with these spatial tasks and vice versa.
Interesting.
Yeah. So it's kind of its own unique set of skills.
Okay. So for our deep dive today, we're looking at how this spatial ability actually impacts how people learn, especially when it comes to visual information.
Right.
And we've got a really fascinating meta-analysis to dig into. It's by Tim and Huffler from 2010.
That's right.
And he pulled together quite a bit of research here. He looked at 27 different experiments from 19 studies.
Yeah, that's a substantial amount of data to really give us a good picture of what's going on.
Right. And this is super relevant, I think, for anyone who's, ever tried to learn something new using a diagram or a chart or nowadays even, an animation or a 3D model.
Absolutely. And think about all the different ways that we encounter visual information in our lives.
Right.
If you're taking an online course, you're probably looking at, slides and diagrams.
Right.
If you're trying to understand a scientific concept, you might be looking at infographics. Even just following a map to get somewhere, these spatial abilities are coming into play all the time.
Yeah, they really are. And so what we want to do today is really pull out the most important insights from this meta-analysis.
Okay.
For our listeners, how much does your spatial ability actually influence how well you learn from different types of visuals, and what are the practical takeaways here for you in your own life?
Absolutely.
Okay, so let's jump right into the main finding here.
Great.
What did Huffler discover about the overall effect of spatial ability when learning with visuals?
Well, across all those studies, they found a really interesting pattern.
Okay.
People with stronger spatial abilities consistently showed a moderate advantage when it came to learning from visualizations.
Okay, so they did better.
They did it better.
Okay, but moderate advantage, what does that actually mean?
Right, so researchers use this thing called an effect size to kind of quantify how big a difference is. And they use this letter R. And in this case, they found an R of 0.34.
Okay, so what does that 0.34 R tell us?
Well, in practical terms, it means that if you're someone who can easily picture things in your mind, mentally rotate them, manipulate them, you're probably going to find it a bit easier to grasp new information. When it's presented to you visually, it's going to kind of click a little bit more readily.
Okay, that makes sense, and that's good news for those people.
Right.
But I'm guessing it's not quite that simple, right? Like spatial ability isn't just one single thing.
That's right. It's not a one-size-fits-all kind of deal.
Okay, so let's break that down a little bit.
Right.
We talked about John Carroll earlier and those different aspects of spatial ability he identified.
Right.
Can you remind us what those were again?
Yeah, so he broke it down into 5 key areas.
Okay.
The first one is spatial visualization, and that's really the ability to mentally transform shapes in your mind.
Okay.
So like that classic example of picturing how to fold a piece of paper.
Right.
Or if you're looking at those, flat tack furniture instructions,
Yeah.
and you can kind of see in your head how those pieces would fit together.
Right.
That's a sign of strong spatial visualization.
Okay, that makes sense then. What's next?
All right, so then you have spatial relations.
Okay.
And that's more about quickly understanding the relationships between objects in space.
So if I show you two different shapes, are they the same shape, just rotated differently?
Exactly, yeah. So like those classic mental rotation tasks where you have to quickly figure out, if two shapes are actually the same or mirror images.
Okay, got it. So spatial visualization is about manipulating shapes, and spatial relations is more about understanding their relationships.
Yeah, that's a good way to put it.
Okay, now what about the other 3 factors that Carroll identified?
Right, so he also talked about closure speed, and that's basically how quickly you can identify a whole object from fragmented visual information.
Oh, interesting. So if I only see little pieces of something, can I quickly put it together in my mind and see what the whole thing is?
Exactly, yeah. And then there's flexibility of closure.
Okay.
Which is similar, but it's more about being able to see different possible configurations from the same fragmented information.
I see. So if I see those same little pieces, can I imagine different ways they might fit together to make different shapes?
Precisely, yeah. And then the final one is perceptual speed.
Okay.
And that's basically how quickly you can compare visual details.
Okay, so spot the difference kind of thing.
Exactly, yeah. How quickly can you find those subtle differences in two almost identical images?
Okay, so we've got these 5 different aspects of spatial ability. Now, which of these did Huffler's meta-analysis focus on?
So they primarily focused on the first 2.
Okay, spatial visualization and spatial relations.
Yeah, those are the ones that have been studied the most.
Okay, makes sense.
In relation to learning. So they had the most data to work with for those.
Got it. Now, did they find that one of those was more important than the other?
That's actually one of the more surprising findings. They didn't find a significant difference in how much influence spatial visualization and spatial relations had on learning with visualizations.
Really?
Yeah, so it suggests that both of those abilities, both being able to mentally manipulate shapes and being able to quickly understand spatial relationships, they're both important when you're trying to learn from visual aids.
Okay, so both play a role. That's interesting. It makes sense, though, that they'd both be helpful in different situations.
Exactly.
Okay, so but what about those other 3 factors that we talked about? Did the meta-analysis look at those at all?
It did in some of the studies that were included.
Okay.
For example, some studies looked at spatial orientation.
Okay.
So that's your ability to imagine how a scene would look from a different viewpoint.
Right. So if I'm standing here and I turn around in my mind, can I picture what it would look like behind me?
Exactly.
Yeah.
And some studies looked at spatial reasoning, which is sometimes measured with those abstract visual pattern tests, like Raven's progressive matrices.
Oh, yeah. Those are those puzzles where you have to figure out what the next pattern in the sequence would be.
Exactly. Yeah. And interestingly, in the few studies that did look at these, the effect sizes seem to be even larger.
Oh, so those might be even more important.
Potentially, yeah.
Yeah.
But the researchers who did the meta-analysis, they decided to focus their main comparisons on spatial visualization and spatial relations because there just wasn't enough consistent data on those other subfactors to draw really solid conclusions.
Right. They wanted to make sure they had a good foundation to compare things on.
Absolutely.
All right. So that makes sense. Okay. So big picture, we know that having stronger spatial abilities generally gives you a leg up when learning with visuals. But let's get into the nitty-gritty here.
Okay.
What about different types of visuals, like animations versus static pictures? Those still images.
That's a really crucial question. And it's one of the key findings from this meta-analysis.
Okay, tell me more.
They found that spatial ability has a bigger influence when you're learning with static pictures compared to when you're learning with animations.
Really?
Yeah, so the correlation for static images was R equals 0.41.
Okay.
But for animations, it was only R equals 0.25.
Huh. Okay, and is that difference statistically significant?
Yes, it was a significant difference.
Okay, so that's a pretty big deal.
It is.
So it means that if I'm trying to learn something from a diagram in a textbook, my spatial ability matters more than if I'm watching a video about it.
Exactly.
Why is that?
Well, the researchers think it might have to do with what they call a compensating effect.
Okay, compensating effect. What does that mean?
Well, think about it. An animation basically shows you how things move and change over time.
Right.
It's kind of giving you a ready-made mental model
Okay.
of the process. So you don't have to build that entire model in your mind yourself.
Ah, okay. So if I'm not good at visualizing how things move and change, an animation is doing that work for me. So it's
Exactly.
kind of leveling the playing field.
Right.
Okay, that makes sense now. But what about those static images, those still pictures? How do those work differently?
So when you're looking at a static image
Okay.
and you're trying to understand a process or a complex relationship,
Uh-huh.
you have to really use your spatial abilities to kind of fill in the gaps,
Okay.
to imagine how things connect, how they might move, how they change over time.
Right.
And people with high spatial ability are naturally better at that kind of mental construction.
So they have an advantage.
They do?
But for someone with lower spatial ability,
Right.
that task of building the mental model from a static image is much harder.
It is, yeah.
Okay, so animations are almost like a shortcut
In a way, yeah.
for people who don't naturally visualize things easily.
Yeah, they can be a really helpful tool for those learners.
Okay, that's a good takeaway. If you're struggling with the static image, maybe try to find an animation or a video that explains it.
Yeah, that's a great strategy.
Okay, now what about 2D versus 3D? We're seeing more and more 3D models and visualizations in educational materials online.
Absolutely.
So how does spatial ability come into play there?
Well, this was another really interesting finding,
Okay.
and it was kind of counterintuitive.
Okay.
They found that 3D visualizations actually seemed to reduce the importance of having high spatial ability.
What? Really?
Yeah, compared to 2D visualizations.
Huh. You would think it would be the opposite.
You would think so, right?
Yeah, because you're dealing with depth now.
Exactly.
You're dealing with an extra dimension.
But the effect size for 2D visuals was R equals 0.35.
Okay.
And for 3D visuals, it went down to R equals 0.23.
So a smaller effect.
A smaller effect, and this was a significant difference again.
Wow. Okay, so 3D is actually better for people with lower spatial ability.
It seems that way.
Why is that?
Well, the researchers think it might be because 3D visuals provide more depth cues.
Okay.
They give you that sense of depth and volume right off the bat.
Right.
So even if you're not as good at mentally manipulating 2D shapes, those extra cues in 3D can help you understand the spatial relationships more easily.
I see. So it's almost like the 3D image is doing some of that spatial work for you.
Exactly.
Similar to how animation's going to give you that ready-made mental model of movement.
That's a similar idea, yeah.
Okay, but is it really just the 3D-ness that's making the difference, or could it be something else?
That's a good point.
Yeah.
The researchers did acknowledge that in the studies they looked at, a lot of those 3D visualizations were also more realistic.
Okay.
And they often allowed for interactivity. You could rotate them, zoom in and out.
Right. Yeah.
So it's possible that those factors also played a role.
Okay, so it's hard to tease apart exactly what's causing that reduced reliance on spatial ability.
Yeah, could be a combination of things.
But it's still a promising finding. If you're trying to teach a concept that's inherently three-dimensional,
Right.
using a 3D representation might make it easier for a wider range of learners to grasp.
Yeah, and I think that's something to keep in mind for educators and designers.
Absolutely. Okay, so we've talked about animations versus static pictures, 2D versus 3D. What about all those other features of visualizations that we often see, like the level of realism, the interactivity, audio text, those kind of things?
So they looked at a whole range of those factors.
Okay.
For example, they looked at the level of realism in the visualizations from very simple schematic drawings all the way to photorealistic images.
Okay.
And there was a trend suggesting that the less realistic visualizations might actually rely more on spatial ability.
Really?
Yeah, so it's almost like you have to do more mental filling in the gaps when the image is more abstract.
Interesting. So a simple line drawing might actually engage my spatial skills more than a photo?
It seems that way, but these differences weren't statistically significant. So we can't say for sure that highly realistic visuals always act as a substitute for lower spatial ability.
Right, right.
But it's an interesting area for future research.
Yeah, that is. What about interactivity? We always hear how important it is to have interactive elements in learning materials.
Right, and they looked at that too. They compared visualizations that were system-paced, meaning you just watch them,
Right.
to self-paced where you can control the speed, and highly interactive where you can manipulate things, click on things.
Okay.
And surprisingly, they didn't find any significant differences.
Really? So it doesn't really matter if I can interact with the visual or not?
Well, at least in the studies they reviewed.
Okay.
Simply having that control didn't seem to make up for lower spatial ability.
Huh. Okay, that's interesting. And What about adding audio to the mix, using narration or sound effects along with the visuals?
Yeah, they looked at that too. They
Oh, yeah.
compared using just visual information to using both visual and auditory information.
Okay.
And again, they found no significant difference.
Really? So even with that extra auditory channel, spatial ability still matters just as much?
It seems that way, yeah.
Huh. That's surprising. We often hear about the modality effect,
Right.
which says that using both visual and audio channels can actually be better for learning because it reduces the load on your visual processing system.
Exact.
But here, it doesn't seem to be changing the role of spatial ability.
Right.
That's fascinating. Okay, and what about those kind of simple instructional aids, like having text labels on the visual or narration that explains what you're seeing?
Right.
Or even things like arrows or highlighting to point out important parts?
Yeah, they looked at those too, and they found that those didn't significantly change the impact of spatial ability either.
Really? So those things are helpful.
Yeah, they're generally considered good instructional design practices,
Right.
but they didn't seem to specifically compensate for differences in spatial ability.
Okay, so it seems like the most important factor is really that fundamental format of the visualization, animation versus static 2D versus 3D.
Yeah, those seem to have the biggest impact.
Okay, now did they look at whether the content of the learning material made a difference?
They did.
Like the subject area or the complexity of the topic?
Yeah, they looked at a few different things.
Okay.
First, they looked at the instructional domain, so whether it was biology, physics, chemistry, other subjects.
Right.
And they didn't find any significant differences there.
Okay, so regardless of what subject I'm learning about, the relationship between my spatial ability and how well I learn from visuals is pretty much the same.
It seems that way, yeah.
Okay, that's interesting. What about the complexity or the abstractness of the topic?
So they looked at that too. They compared topics that were at a molecular level, things you can't directly observe,
Right.
to things that were observable in everyday life, and then to more abstract concepts.
Okay.
And there was a trend suggesting that more abstract topics might rely more heavily on spatial ability.
Okay, that makes sense.
But again, this trend didn't quite reach statistical significance.
Okay.
So more research is needed to really confirm
Yeah.
that.
Right, but it makes sense if I'm trying to visualize something I can't actually see in the real world.
Yeah,
My spatial skills are going to be more important.
exactly.
Okay. Now, they also looked at the type of knowledge that was being tested, right?
Okay.
Like whether it was just remembering facts or actually applying that knowledge to solve problems.
Yes, and they found that the advantage for high spatial ability learners held true for both types of knowledge.
Really? So it's not just about remembering what you saw.
Right,
It's also about being able to use that visual understanding to solve problems.
exactly.
Okay. And what about the learners themselves? Did their age or their prior knowledge make a difference?
Surprisingly, they didn't find any significant differences based on age.
Okay.
So whether you were a school student or an adult, your spatial ability had a similar impact.
Huh. Interesting. And what about prior knowledge? Did that change things?
Again, surprisingly, they didn't find a significant effect of prior knowledge.
Really?
Yeah, so whether you already knew a lot about the topic or not, your spatial abilities seem to matter just as much.
That's very counterintuitive. You would think that if you already have a lot of background knowledge,
Right.
your need to rely on your spatial skills might go down or maybe even go up.
Right.
But this study didn't find that.
Right, and they did point out that there was a bit less data for this comparison.
Okay.
So more research would be helpful to confirm this finding.
Right, but it's still very intriguing.
Absolutely.
It shows how complex learning is and how these different factors all interact with each other.
Exactly.
Okay, so we've covered a lot of ground here.
We have.
Let's try to pull it all together. What are the key takeaways from this deep dive into Huffler's meta-analysis for our listeners?
All right, so I think the most important thing to remember is that, yes, your spatial ability does give you an advantage when you're trying to learn from visual information.
Okay.
But the way that information is presented to you, the format of the visualization,
Right.
that can make a big difference and can even help to compensate for differences in spatial ability.
Okay, so if I'm someone who struggles with visual information,
Right.
what should I be looking for?
Well, if you find yourself having difficulty with static pictures or diagrams,
Okay.
try to find animations or 3D representations of the same information.
Okay.
Those formats tend to provide more of that spatial structure and movement explicitly, so they don't rely as much on your own internal visualization skills.
Right, so those can be really helpful tools.
Yeah, they can be.
Okay, and for those of you out there who are creating learning materials or presenting information visually,
Right.
what should you keep in mind?
Well, keep in mind that not everyone has the same spatial abilities.
Right.
So providing multiple formats can make your information more accessible to a wider range of learners.
Okay, so maybe offer a static diagram and an animation and maybe even a 3D model if it's appropriate.
Exactly.
Yeah, great. And remember that effective design is crucial for everyone.
Yes, absolutely.
Clear, concise, relevant visuals are going to benefit all learners regardless of their spatial skills.
Right. Well-designed visuals can really enhance understanding for everyone.
So as you go about your learning journey or as you try to explain complex ideas to others, think about these findings.
Right.
Could incorporating more dynamic elements like animations or 3D models make your information more engaging
Yeah,
and more accessible to a wider audience?
absolutely.
And how do you personally learn best with visual information?
Right.
Do these insights resonate with your own experiences?
Yeah.
What other individual differences might be playing a role?
It's definitely something to think about.
It is, yeah, and explore further in your own learning.
Exactly.
Okay, well, this has been a fascinating deep dive into the world of spatial ability and visual learning. Thanks so much for joining us.
My pleasure.
We'll see you next time.
See you later.